Okay, we're going to look at this example from your textbook. So first we're going to do this using what is called a random number table, and this is a manual process, so it does not adapt very well for real life problems. But we want to go through this to understand what are the concepts involved, and then we will look at automating that process using Excel functions. So here is a radial tire um, company. So it determines policy for managing inventory. So we want to simulate daily demand for a number of days. So how much is the demand for each of those days? So we want to first establish the probability distribution for demand. And how do we get the probability distribution for demand? Well, we look at the past historical data. So historical demand data says that over the past 200 days, these are the frequencies with which the demand occurred for tires. So there were 10 days with no demand at all, 20 days with 1, 40 days with 2, and so on. So you have the frequency distribution, and when you divide the total number of days into each frequency, what you get is a relative frequency, and the relative frequency has all the properties of probability, which we already saw in chapter 2. So the relative frequencies can then be used as probability. So now we have the probability of zero demand is 5%, probability of demand equal to 1 is 10%, and so on. So these probabilities can then be used to build a cumulative distribution. So cumulative distribution will go from 0.05 all the way to 1, right? So first probability 0 to 5%, and then 6% to 15%, then 15 to plus 20, 35%, and so on. So you have a cumulative probability going like that. So if you now convert this cumulative probability into percentages, so you get 1 to 5, okay, and then 6 to 15, 16 to 35, 36 to 65, 66 to 85, okay. So like that, 66 to 85, and then 86 to 00, 00 being equivalent of 100. So if you have two-digit numbers, okay, so now we will associate this range with demand of 0, this range with demand of 1, and so on. So if you have two-digit numbers going from 0, 1 through 0, 0, and if they all have the same probability of getting selected, just imagine a huge vat of coins. Each coin is numbered 0, 1, 0, 2, 0, 3 all the way through 0, 0. Okay, so 100 coins. Now you shake the vat up and then select one number. Okay, and what that number says, okay, if it says 7 for 0, 7 for example, then it has fallen in this range, and we will assume the demand to be equal to 1. Okay. And then you again shake it up and select another coin, and if this coin happens to be 75, okay, now 75 is in this range, so you will set the demand for the next day to be 4, and so on. So it's like this. So you're going from 0, 1 through 0, 0. That's your cumulative probability. So if the number happens to be in this range, it'll represent 1. Okay. This range, 2, 3, 4, 5. Yeah. Okay. So that's what this is. So we start with computing or estimating probability using relative frequency, and then computing cumulative probability, and then assigning range for random numbers. Okay, and then we generate random numbers. So here is a table in the back of your textbook that gives you random numbers. Okay, so and here this random number table is kind of not very good because it has only two digits, but usually it'll have like string of numbers going across, and to add to the randomness, you would select at random some starting point and then decide which way to go, either left or up or right or down or whatever. And then you will select how many numbers you want. Sometimes you may want 4 numbers or 3 numbers and so on. So here it's a very simple example. So we are starting out here and going down like this. So first day 52, second day 37, third day 82, and so on. So then by comparing that number against this table, we decide what the daily demand is going to be, and based on that we compute the expected value of daily demand. So it's a very simple example. Let's look at how it is done in Excel. Okay, so we start out with entering the possible demands and the frequencies from historical data. So we have 0 through 5, right? And these are the frequencies, and when you sum that, that gives us the total number of observations in the sample. Now we divide that into each of these frequencies, so that divided by that, so that has to be absolute referenced. So then what we get is the relative frequency or probability. So you copy that and you have the individual probabilities for each of the demands. But we need cumulative probability so that we can assign random number ranges. So that would be sum of that with that, except that close parenthesis in the first D8, make that into absolute reference. So then you'll get the absolute cumulative values. All right. Then you set up the range. So you'll be 0, 1 through 0, 5. Well, it automatically changes to date. So I'm going to start with an apostrophe 0, 1 through 0, 5. And then 0, 6 through 15. And then 15 through 35, 36 through 65, 66 through 85, and 86 through 00, representing 100. All right. Now we want to simulate for 10 days. Right. So first day we get a random number from the table, which is 52. Then we look at 52 is here, so we say demand is 3. Okay. Second day we again draw a number from this random number table, which is 37. So we write 37 here. Okay, so 37, so the demand is 3 again. Okay, so third day, again we go to the table, third day is 82. So 82, now 82 is here, so the demand is 4. Okay, so keep going like that. Okay, so these are the demands for each of the 10 days. Then we find the average demand. Okay, so this is the rudimentary concept. Now we want to automate this, and we will look at that in the next video.